So we've looked at GEC's legacy IDE. We want to now look at our new AI system called DataBlock. We learned a lot actually in the past couple of years using AI inside GEC, but one thing we learned is there's more that we need. It's not sufficient. So a decision was made, rather than to address those inefficiencies inside GEC, we would launch another project called DataBlock-AI. And DataBlock-AI is a node-based system, so it's blocks that you stack up and you connect, and you define your AI services in there. And a couple things before I show you the platform is DataBlock has read-write systems, and it has AI and machine learning systems. So we've already looked kind of at the AI and machine learning systems. They're similar to what we see in the GEC IDE. We have commercial and open source large language models, commercial and open source machine learning models, and we can also do our custom machine learning models. But inside the DataBlock, we also have read-to-write systems, so you can access a database and read from that database or write to that database from inside the DataBlock environment. Same thing with a web page. You can use HTTP requests and read or write to a web page. And then, of course, there are file-based read-write capabilities. So you just, from your hard drive, from any file structure, server or your hard drive or whatever, that you can upload a file into here and interact with that file from an AI perspective. So you can imagine where you have a database connection, you have an HTTP connection, and you have a file connection in the same AI services. Data from those assets, from those sources, can be mixed with processing from any or many of these AI models. I'm just going to go to DataBlock.AI.com and log in here and show you a couple of these nodes that we have. They're actually interesting. So before we talk about the nodes, we'll just talk about what's going on here a little bit. A gateway it's a API endpoint, so it's an access to this microservice from anyone who has access to this endpoint. So another website like GEC or like Google or like somebody else could access this microservice if they wanted to. And then what we have is workflow on the right. If you think of workflow on the right and information on access on the left. For this workflow, on the left side, we're reaching out and grabbing information, bringing it into the workflow and passing it on, and then we're grabbing more information, bringing it into the workflow, or processing. This is a database node, so we're reaching out to a database and bringing database information in here, and then we're mixing the results from this with the results from this, and we're running another process here. So we just have to think about it that way. The structure is a service is the parent and a module is the child. And so in the pure GPT service is getting pretty complicated. And I'm not done with it. So really, rather than to build more complexity into this module, I would actually add a new module, and then wherever the data is such that I want to branch it off and send it someplace else, I can come into here and share this workflow node with another module. So in that way, the complexity that you see here is compounded exponentially by the ability to add multiple communicating modules into one service. Okay? And you'll see that we've got workflow 1, workflow 2, workflow 3, and then it goes to a branch node, which is different. So whatever data gets sent into this branch node, it gets sent into 2 different processes instead of just one process. So we're not bringing in new information with this branch node. We're taking existing information and running 2 AI processes on that information. So a branch node is unique. As we already talked about, we could be getting information from a database node here instead of from a GPT node, in which case we would have to access the database and then we'd have to write the query. Or instead of a database node, we could be getting information here from an HTTP node. And in this case, we would have to access the web page and decide which method that we're going to use to handle the data back and forth. And remember, these are both read or write. And I think some of the most interesting nodes here are the conditional nodes. And this is sort of a procedural conditional node here, where your data is going to come into the conditional node at the top, and you can do a conditional, and if it's false, it's going to run this branch, but if it's true, it's going to run this branch. And this is really just like classical logic, right? You got to write your if-else condition in here. This, though, is a GPT conditional node, which still has the true and the false branches, but in here we're not using classical logic. We're using a GPT to make a decision. The conditional nodes are often categorical. I mean, you have to have a perfect match, and there's no subjectivity to the decision process at all. In a GPT node, it's actually moving toward a new form of computing, a more intelligent form of computing, really.